hello. Okay, so my name is Sylwester Brzęczkowski. I work for Mirantis as junior software Python engineer. This is my first presentation ever, and first presentation in English, so sorry if I forgot how to speak, for example. And few words about presentation. Riding a bike, driven development. Riding a bike refers to something that we need to learn at some stages of our life, and it becomes natural after some time. So natural that we do not need to think about riding a bike while we are riding a bike. So that's the story. Presentation consists of tips and tricks which are well known, I believe, for advanced pythonistas, but also a couple of less known practices based on my own experience. Developed working on Fuel. Fuel is a product which I am working on in Mirantis. So we have like 11 tips and tricks which are connected with each other. We have only one gap, I believe, between them, but that's okay. So let's start. There's no reason to wait, and we'll start with a pretty simple thing. And we will start with a pretty simple thing and then move to some more complicated examples. There are three categories which are describing what we will learn from each slide. We have here a red dot, which means that it will be about performance and optimization. We have green dot, which means that it's going to be a good practice. And we have is a trap mem, which means it's a trap. What does it mean? We will see later. And as I said, let's start with something pretty simple. One of the most awesome things in Python are multi-line strings. Do you see it? Maybe? It's okay? It's visible? Okay. So we can write text in it, and it's pretty natural how we type it, and that is awesome in Python, and that will be printed out just like this. And if you program some kind of 2D game, console game, which I did in my first year of studies, you can do some ASCII artworks like this tank, and it will be printed out pretty awesome. But it has some disadvantages. Just like we see here, we have function which defines some text and print it out. Whatever, that doesn't matter. But it will be print out something in some shape of it. You can see that we have all white spaces, all white spaces in it, like tabs, new lines, and so on. And sometimes it's not desirable. Here we have some example function which intends to be a real life example. I make some efforts to make more indentations to show the problem better. And as you have seen, as you saw a second ago, it will be printed out with all white spaces, all tabs, and so on. And also, it causes some errors for some of the interpreters like IPython. We can do something like this to make it happen. Use concatenation using plus operator. But in my opinion, I don't know what you think, but putting backslashes anywhere in the code is just ugly. So I don't like it. Python has something that is, I believe, hidden. I was surprised how many people doesn't know it. And that is that Python interpreter will concatenate all strings inside any parenthesis. That means we can do it like this. You see that we have parentheses here, and Python concatenates it whatever it will be. So if there are strings, they will concatenate, but they will concatenate as it is. So we have to remember about white spaces at the end of the string or new lines, whatever is desirable. what we can use it for. The most common example is a pretty long regular expression. We can split it into many lines. That makes it easier for debugging. Right now, we can comment it really well using that feature of Python, hidden feature of Python of string concatenating inside parentheses. So that's the most common example. So as I said, this was pretty simple. The first thing here. Let's move to the next one, and let's stay with regular expressions a little bit longer. We have here some text, an example text like "Hi, I'm Sylwester, here's my GitHub address," and so on and so on. And let's say I want to make all links and hyperlinks email addresses bold. How you would do that? I can show you a pretty simple example. That is just first thing that comes to my mind. So we have here some definition of function. There is a pretty simplified regular expression, so it doesn't matter how it looks like. We have some scheme email. It catches some subdomains, domains, and path. It is pretty simplified and doesn't work for all cases, but here it works, so that's enough. I decided to split the problem to smaller chunks. Just like here, I want to process each line separately. I thought it would be good, and we tried to match the pattern for the line. If it matches, we do some magic to put this bold start and bold end strings to this line. If it doesn't match, we just add to our result string this line, and at the end of for loop we add a new line because split removes it, as we all know, and this is needed, and it works. So we're happy, it's awesome, but there's a problem. If you want to put, for example, two email addresses, two links in one line, and there is a place where this algorithm doesn't work. So what to do now? Actually, why it doesn't work? Because we split it, each line to be processed separately. That's why it doesn't work. We could use find all or something like this, but there is a simple solution in the regular expression library of Python, which is reg. So let's try again. Let's start from the beginning. We have here a pretty simple definition. We have the same regular expression as on the previous slide, and we have something like this. Sub function receives, actually takes arguments like this, that the second argument, which is usually string, that will be put instead of this replaced one, we can pass there a function that receives one argument, which is match object. We can do with it whatever we want. So I will show you a pretty simple example how it works. Here we just replacing all words with the numbers that are the length of each word. So that is simpler and easier to understand. So as you can see, it's like hidden. I didn't know it before I started the work in the presentation. We can move further. There's a more general topic, laziness. Laziness in programming languages is quite common. So, why I'm talking about this. So we have an example here about laziness. We know that dictionaries have a get method, which is nice. It allows us to not check if some key exists in dictionary. This is pretty nice. and we do not have to put it into another try except block, which is also ugly in my opinion. And we can just provide a default value or don't provide any value that will be known then. And so nodes number will be either number of actually value of number from this dictionary or result of compute nodes number. But why is it bad? Because we have to first, that is how Python works, we have to first compute nodes number. This is very heavy function, it consumes a lot of energy of our computer, a lot of memory, a lot of processor's time, and this is not desirable. So we should, actually Python will first execute it, first count this number, then put it to, as a second argument to get, and even if number doesn't exist in dictionary, it will be executed. So that is not really nice. We will lose a lot of energy for that. That is not desirable, as I said. And we can do something like this. We know that our operator doesn't have to return Boolean, like true or false. In example, actually, true or false. It also can return objects, just like here, but that is not the case. That is like, let's say, obvious. The case is that it's lazy. So if the first argument of operator OR is already true, it will be returned. It will even do not look at compute nodes number, and that is what we want to achieve. And that is processor time saving and so on. And this is equivalent to this one. Thanks to that, we are saving the time, the memory, and this is an example of good practice and good performance actually, because we don't waste the time. We have another example of laziness in Python. In my opinion, property is the best thing for that. We have some session that requires some system call and so on, and it's pretty costly and it's heavy, and we take in some resources, for example, port. I don't know what get session is, just an example, right? And we have some send method, which uses self session. So what is the problem here? There is a possibility that we will never use send in whole program running. So the session will be created for nothing, right? That's why we use this like, let's say, lazy evaluation of creation of this object. And the session will be created at the second line of send, right? On the self session exactly. That is good, because if we use it many times, then it will be created also just once, only by the first time. And I encourage you to use laziness everywhere. Now there's going to be a slide about this. This is just like our base for the next slides. I just want to remind you something. And what is the difference between these two functions, as we can see it? On the left, we have a separate function for multiplying. It's pretty simple. And we have some kind of for loop, and inside this for loop, we are still executing this function. And on the right, we do it in place, like in line. So that's the main difference. We have, for example, list that is consist of 10 elements. Also, I want to say that is Python 2. That's why it's a list. And we have the same for the second thing. And we can see that the function on the right is 1.2 times faster. What if we have 1 billion elements? the function on the right will be 1.8 times faster. So I just wanted to show you by the slide that function calls are quite heavy in Python. And also, this is not an example of good practice, because if multiply function will be more complicated, it's not okay to put it in line. It's pretty fine to define a separate function for that. So that's why it's not a good practice. And we have some example here. What we do here, we have two classes, N and B. B have an item which is actually an object of A, and we have some big loop function which iterates something, whatever it is, million times, right? We have L append object.item times something. It doesn't matter actually, but how we can increase the performance of this function? What are your first insights? Do you have any ideas how we could improve it? Yield. Actually, the intention was to take an array or list and convert it somehow. Cache item. What does it mean? Yeah, you have a good intention. So something here could be improved. And there is simplified example, just to show how Python is looking for an attribute for an object. So this is pretty simple. We have just we have item as a class attribute. We have item also as an object attribute. And what happened if we do this inside of Python, under the code, so to speak? So we need to say, we need to say, first of all, that many of Python objects have something like dict, dict attribute, which actually represents a namespace for a specific class. So what is going on if we're trying to print e.item? Python looks for an item in Python provided attributes, so-called because it's not official. So these items are like these things are like dict, docked, hash, and so on. We can see these things, for example, running dir on this function object or whatever, and subtracts actually these things from dict, yeah, whatever, it doesn't matter now. And so it's trying to find it. Then Python looks for a data descriptor which name is item, and if exists, returns a result of get method, of its get method. What is data descriptor? There is no time for it, and there is no place for it to explain it. I can say that there is an object that implements get or set or delete method, and this is just a pretty nice way to play with Python attributes. The most important thing is that, as you can see, it has higher priority in order to looking for an attribute in object than anything else except for point 1, and that is the most important thing here. And the next thing is Python looks for an item in e.dict. That is looking for attribute, object attribute, literally. Then Python is looking for non-data descriptors. So the second point is doubled. Then it checks in class dict. So then it actually checks class attributes. In point 3 we have object attributes, in 5 we have class attributes. That is how Python is looking for an object, for an attribute of an object. And R our e.item is found in the point 3. So is it fast enough? We done already many lookups there before the point 3. And also that's why we have here object attribute, not class attribute, because it was found earlier, and the class attribute is another 5 place. So, as you suggested, we can cache the item just like this, and we are saving a lot of lookup. Remember that actually, I don't know if you notice, but we do this lookup in e-class dict and all of these bases. So this is a lot of lookup time wasted. And in this example on the left, we do it a million times. It's huge. It's a huge waste of time. And we can cache it just like this. Also, for the better performance, even better performance, we can cache append the function of list. We also gain for some time, and you can see that the best example is 2 times faster than the first one. So this is an example of good practice. It's not so ugly, so it is a good practice, and is for sure a good performance. And there is our first riddle. I have 2 of them in the presentation. What do you think it is? Come on, first guess. Yes, it's processing. So there's our first gap in the presentation. It's processed. Let's talk about sets. I won't talking about sets as a just data type. I will tell about sets like about the utility that can be used to everyday work. So sets are very useful, as I said. It's a collection of unique items, unordered unique items, because unordered does not supply indexing and sizing, etc. Set does not implement hash, just like list, so it cannot be used as a key in dictionary. Frozen sets implements it, since it's immutable. Sets are implemented like dictionaries. They use hash tables, so they cannot contain mutable objects, just like dict keys. And we have here something really nice. We have in the first line we have a list, and the second line we have a set, and we're trying to measure the lookup time. We have here 16.2 milliseconds for only 10 loops, and we have here 191 nanoseconds, right? That is about 85,000 times faster. Actually, it is a little bit cheating, because I picked the worst case ever for list, but that's okay. You will find out why it's the worst case. So the lookup time complexity in sets is O of 1. What does it mean? That means that it's constant. It doesn't matter what set have inside, what kind of data and how much of it. It doesn't matter. And for list, this lookup time is O of n, where n is a number of data, the worst case. Actually, I wanted to say that why is that? Because list, for example, if we we want to remove first element from list. Actually, I will talk about that later. Sorry. Okay, so more about the utilities that sets are giving us. We can easily check if list have duplicates. This is pretty simple to compare lengths of both containers. We can easily find conflicts. For example, we have teams, and to these teams can belong only like one person. One person cannot be in the two teams at the same time. So we can easily find conflicts if we do some mistakes and so on. This is nice utility. That is because sets implements all mathematician operations on sets like union, difference, symmetric difference, intersection, membership testing, and so on. We have some comparison of Mirantis and others. We can see easily the difference between Mirantis and others. This is a joke, I believe. And now we have next task. Actually, this is task for you. Looking for a list, for an element in a list. We have some example class that represents person. We have name attribute and surname attribute, pretty simple. And we have a list of people, right? And the task is, what if I want to get from this list a Daniel Morris object? And I assume that this is an ordered and cannot be sorted, and we can, thanks to that, actually because of that, we cannot use binary search. We should use linear search. So, how to do it? I don't hear you, but something like this, maybe. This is the simplest example. Excuse me? I don't know what set we will have here. I don't know.
If you said that set is implemented like dictionary, and you have get method in dictionary.
No. I said I mean that they uses cache tables. I don't know where you are. Sorry. Yeah. And why this algorithm is really good? Because if person is found, we stop iterating to the end of the list. But it's too simple task to do it in so many lines of code. That is not enough. And we have an example how to do it faster. We can look for Daniel in that way using list comprehensions. And if it's found, we can assign the variable again. That's okay. But this is not so good as the first algorithm. Why? Because even if Daniel is found, we are iterating after Daniel, like all the objects after Daniel. That is bad and doesn't bring anything better than the first one. We can do it something like this. Actually, it is the same example as the first one, but we use pop. That are things that I just saw in our code, reviewing fuel and so on, and I'm making it better. And we finally here using something that is just created for such thing, which is filter with some lambda function, and we are extracting the first item from it. We could do it also in the first example, but I mean the second example with comprehension, but this is just a different solution for the same problem. And it will also raise an error in Python 3 because filter is no longer a list, it's a raster. And there is a thing in Python which is just, maybe it's not created for that, but it is semantically really nice. This is next. We can use next for that. And why it's awesome, comparing to the previous ones. Once we find Daniel, we stop iterating. If lists have, for example, 1 million elements and Daniel is on the first place, that's a waste of time and energy of our computer. So next allows us to do it better. Also, it has generator expression. Let's say it's comprehension, but it's generator expression. And that is already really Pythonic, and we should use it everywhere. And but it can rise stop iteration if Daniel is not in the list. So we can provide a default value here, here is known, it could be whatever you want to build, and it won't rise stop iteration, it will just assign known to found. That is quite nice, and you should use it everywhere, really, because it's as good as the first R of our propositions for this task, but it's faster and it's cleaner and it's just more Pythonic. Another task, remove first element from list. We have some list of people from the previous example. I add some rep methods to make it more readable. And there are 3 approaches to do that. We can delve the first element. As you can see, it works. We can pop this element. Also it works. And we can use slice assignment. This is a bit tricky. We actually use this here people's list reference. We're not creating new one, we're not creating new slice, and we're not creating new list. We're using the same reference thanks to that slice assignment, and also it works. So maybe let's check how's the performance of that solution. Quite nice. It's not bad. But what if we have 1 million elements there? You can easily see that these times are bigger, right? If you don't remember from the previous slide, for example, we have for slice assignment 69 or whatever, there's 19.8 milliseconds then. So what's wrong here? Something's wrong. You can say actually now that is a trap. So it's not a good solution in terms of performance. Why? Because lists internally are represented as arrays, and the largest cost comes from growing beyond the current allocation size, because everything must move. So if we remove something from, if we remove something from the first place, everything what is after, so if we have 1 million elements, remove the first one, all 99,099 and so on, must be moved to the left. So that is why it takes so much time, and that is why it depends on what is inside the list. Actually, not what is inside, but how many. Yeah, this is what I'm talking about. Another riddle. What is it? Collections, right. Collections, I want to say about 2 things. Collections and intertools. This is something that every Pythonista should know. And if you don't know that, actually, if you don't use it, that's okay. If you don't know that, that's really bad. So please take a few hours of your time in the evening somewhere in the future and learn it, play with it. I'm going to talk about collections now. I don't want to show all its features, that's why I encourage you to play with it on yourself, on your own. Also, there is no need for it. I'm going to talk about deck only, because I think it's the less known of all collections tools. And what is deck? Deck is actually a double-ended queue. This is actually a well-known data type in other languages like C++ and Java. It implements methods like pop left, up and left, that actually resolves our problem from the previous slides with removing first element from list. And if we do it a lot, I mean this removing, we should use deck. And it has support for iterating, indexing, but not slices, and membership testing. So the simplest actually example showing the actual usage of it is a steal job scheduling algorithm. it does something like this. We have, for example, two workers which are executing tasks from some queues, right? If one worker finishes his queue, he can steal some task from another worker to help him, right? In this algorithm, we steal the last task on the second list, on the other list of workers. Here, I tried to implement the simplest ever example to show how it works. We have some worker factory, which gets primary deck and the secondary deck, and if primary deck is not empty, we popping left, so we take the first element from it and trying to process it. And if primary is empty and the secondary is not empty, we're taking the last element from this secondary queue and trying to process it. And if nothing happens, then we just break the loop. So that is the end of execution of a worker. And we have some simulation of really hard work, which is time sleep. And here we create some decks. This is the same, but in different data types, right? Thanks. We have two workers. This is fast worker, which waits for 1 second, and the slow worker, which waits for 3 seconds. We have we see that as a secondary deck, we have, for example, for fast worker, the secondary deck is a slow worker deck, and the opposite for the second one. And we put it in the threads, so they will run simultaneously. And there is an output. We see that fast worker is just faster, and it finishes it's saying that primary deck is empty, helping others, and is taking the last task from the secondary deck. This is the simple use case for deck. That is this is so not well known as the others. Now let's talk about iter-tools. Just a little bit. We have here a chain that allows us to, I would say, concatenate different, or concatenate and glue different iterators. We have here 3. First is a list, the second is a tuple, and the last one is a generator expression. And you can see that it works. I also use list to make it happen faster, to see the results. The next one is product. If you have ever implemented 2D game, console game, that is pretty useful to print them up. And I remember that was painful, and we have something like product which does the same thing. So this is just good to know. This is a good practice. And we have something like group by. You have some persons from the previous examples. You have Sylwester's, two Marians, and Daniel. We're trying to group it, and what's that? You have two Sylwesters. Why? Any ideas?
Sort. Sort.
It's a trap, actually. Why? Let's look at the documentation, and my friend is right. The operation of group by is similar to unique filter in Unix. Actually, the general thought is that the data must be sorted before inserting the group by. So we have, for example, some key. If the key is the same constantly, then the key changes. We have a new group, and the next key maybe is the same as the before, the previous one. So we change the group. That's why you have two Sylwesters. Okay, so just maybe we should sort it. I just assign lambda to variable. Never do that. It's not okay with PyPy. And use it as a key functions for sorted, and for group by. And now it looks like this. We have one Daniel, one Marian, and so that is super great. So I should look into these groupers objects, see what's inside, and I can see that Marian, which is on the second place, right, one, is empty. So maybe Sylwester is, oh, this should be two Sylwesters, right? Me and Stallone. So what happened now? I say that it's another trap. Let's talk about documentation again. We should read it. The return group itself is an iterator that shares an underlying interval with group by. Because the source is shared when the group by object is advanced, the previous group is no longer visible. That's why using list to show results of these operations is not so good. So remember about that. If we want to have a list, we should iterate every group one by one. For example, here. Yeah, now it works. You see that I didn't execute list for the all iterators. Actually, this is one iterator. I do it one by one in for loop. Now it works, but it brings too many things to remember about. Who actually sort the data before grouping it? It doesn't make sense. So we have something like default dict from collections. It does the same thing, but I think it's better. We don't have to have this data sorted. Just doing it like this, right? We have default dict with list inside. We iterate over all the persons all the people in person list, and append to groups this object. This is quite awesome in comparison with group by, and we can see that it works as well. So in my opinion, it's better, and it's good practice to know that. So I encourage you again to look into iterators and collections. This is a quite comprehensive set of common used problems. Actually solves common problems that we have every day. And I think it's all. So thank you very much for your attention. Thanks. Some links I used, and I used IPython for the testing, for timing, and I used Trello for design scope of this presentation. Thanks for you guys who helped me. And if you have any question, I'm open to hear that. I can actually explain what was I talking about with things that sets are implemented like this. They use hash tables inside to just like keys. Actually, we can say that I'm not sure, but maybe we could easily implement sets as using dictionaries. They'll just put as a value everywhere none or something else, and we can just rely on keys, and that will be sets as well. That's what I meant when I said that. So thanks. Any questions? Okay.